Hello everyone, my name is Seth Chang, and my CNIT 176 final project is the Raspberry Pi Adblocker and VPN. I decided to choose this as my final project as I feel it aligns with my interests the most. I have hopes that the lectures covering the material relate to what I would like to do as a profession in the future. The project is useful for stopping ads that would otherwise appear on your device. In addition to blocking ads, the project is also a useful tool to improve bandwidth usage and increase your network performance. The ad blocker can improve your bandwidth and increase network performance by significantly lowering the number of files being downloaded when you are web browsing. The ad blocker will also make your device more secure by preventing suspicious ad providers from appearing. Ad blockers would also be ideal for a local area network in a house to keep the user's web experience ad-free. The VPN, or Virtual Private Network, is useful as it can stay online throughout the day without having a significant impact on any power usage. You can also use your Raspberry Pi VPN as a way to connect to your computer. The VPN gives the user the ability for other devices located outside of the local network to act as if they were on the local network of the VPN server. Internet Protocol gives the network the capability to have multiple devices interface and send packets to and among each other. Even though my iPhone and Raspberry Pi consist of different hardware while running on different operating systems, the central device or router is able to send packets between the two, giving them the ability to communicate. The ad blocking project using the Pi has direct relationship to what we learn in class. We can relate the Pi architecture to our Weekend 11/12 networking section of class. During this time, we learned that when a local area network is being used, it will be providing network connections to the users via a star topology. A star topology is when all the nodes are being connected to a central device. In this instance, the central device being connected to the nodes is a router. The central device can steer data from one node to another using a point-to-point connection. The more traffic there is, the more data there is being sent across the network. Moving our attention to one of the images on the screen, we can see what a star topology looks like. Nodes are all connected to a central device without being connected with each other. Since the nodes are connected to a central device, if anything were to happen to the device, the network would go down. If a single node failed on a star topology, the network would still be able to run successfully because each node is connected to the device separately, unlike another network using a bus topology where each node is connected, meaning that the network would go down if any of the nodes would go offline. Reading the command lines, we determined that WireGuard has been successfully installed to our Pi. Networking and file systems lectures topics are directly related to a virtual private network. Installing various programs and protocols like Pi-hole and WireGuard give us the opportunity to learn more about file systems. The more you install on your Pi, the more likely it is that you will run into troubleshooting. The VPN is able to accomplish the security and safety of the user by masking and hiding our IP address. Camouflaging your IP address makes the user's data encrypted, making it difficult for your information to be compromised by hackers. WireGuard is an open source protocol that is being used for our VPN. An important part of any operating system are kernels. Kernels act as a bridge going from specific applications and data processes being performed on your Pi. The WireGuard can be found inside the Linux kernel. Completing the Pi VPN provided me with the knowledge to go more in depth with lecture points we covered in class. Some of the lecture points covered in class I am glad I was able to expand my knowledge on is the file systems, networking, and system architecture. The first course of action for the Pi-hole ad blocker is to run the Pi-hole installation script. What this does is install the script that tells the Pi to automatically install Lite TPD web server. The web server that is being installed on the Pi using the installation script is a server package that has been optimized for applications that are embedded. Another plus of installing this web server is that it has a small memory footprint with a small CPU load. The CPU running on my Raspberry Pi 3B Plus is a 1.4 GHz 64-bit quad-core Broadcom ARM Cortex A53 architecture processor. Not only does installing the script make it possible for us to run the ad blocker, it also checks for dependencies which are supported packages for the Pi-hole to be working. After the script is done installing, a series of blue screens pop up, followed by questions about how you want your Pi-hole to be set up. After successfully navigating through the first part of the configuration, another blue screen will appear telling you that your installation has been complete. Once the ad blocker is complete, I will connect my mobile device, in this case my phone, to the DNS server, which will then eliminate the web domains connected to the ads from appearing on the screen. Viewing the slide below, we can see the script that is run in order to install the first part of the ad blocker. Next, we will go to the web interface for the Pi-hole application that is running. To get to the web interface, we will proceed to type in http://10.4.4.167/admin/ which is the Pi-hole's DNS, which is IPv4. In the search bar, we will be typing. Another prompt that was offered during installation was the upstream DNS provider. The upstream DNS provider fetches the IP address of requests that are not blocked or cached. The instructions recommended that I use Cloudflare DNS provider. After the successful installation using the Cloudflare DNS provider, I launched the web browser on my Pi and typed in the DNS address that was provided in the earlier step. The DNS address that I typed into the search bar connected me to the Pi-hole web interface. Upon inspection, the Pi-hole interface provides a lot of unique tools to play around with once we are signed in. A few of those tools on the web interface are query log, which was enabled in the last steps, whitelist, and blacklist. Viewing the image on screen is an example of the Pi-hole web interface prior to the user signing in. The password used to sign in is the one provided to you upon an initial installation. You would not be able to use a device other than your Pi to get the same web address because it is only available to access from your Pi running the DNS server. Moving on, from the initial Pi-hole web page, the user needs to log in. You will log in from the task column on the left side of the screen. We know that we are logged in now because the new screen shows us a broad spectrum of items such as query log, whitelist, blacklist, tools, settings, group management, disable, and more that can be clicked from the column on the left-hand side of the screen. Continuing on with the ad blocker, to set up the DNS server, we select Custom 1 at the bottom of the page. After doing this, the Custom 1 box, the IPv4 box, and the Cloudflare box will be clicked. To know if the ad blocker is working successfully, we need to take out our phones and navigate to the settings of that device, making sure that we find our wireless network when we click the arrow for the Wi-Fi to change the DNS. Once the Wi-Fi settings have been opened for the specific network we are on, we change the DNS server to manual, and then continue by entering in the IP address for our Pi. Once we have manually changed the DNS on our device, we now search for something on the internet. If configured properly, the IP address from your phone will pop up in the client under the Log Terms Data Query log tab on the left column of the web browser for Pi-hole web interface. So I went to my phone and searched something. When the timestamp came up on the web interface, I knew I had done it. I knew I had successfully completed the ad blocking assignment. Viewing the query log on the Pi-hole interface would also show me the domains being blocked on the phone that I was using. The ads that have been successfully blocked from your device will then appear in red. Viewing the bottom of the screen, we can see the successful ads being blocked. The process to set up the VPN was much like the ad blocker. The Pi project will begin with the installation of the script Pi VPN. Using the installation script from the Pi VPN GitHub page, following the execution of this command, you'll be asked a series of questions like in the Pi-hole project. One crucial step in the initial configuration of the Pi VPN is to select WireGuard as the type of VPN we want to install on our Pi. After the initial steps are complete, by navigating through some of the questions that the installation presents the users with, we will proceed to then set up the VPN. In a new terminal, once the system reboots from installation, we will run the command sudo pi vpn add. After running the command, we will be asked for the name of the client. In this project, the client's name is Seth. In the initial configuration of the Pi VPN, we were asked if we wanted to choose either OpenVPN or WireGuard, and we have chosen WireGuard. Choosing WireGuard gives us the ability to type in the command Pi VPN QR to generate a QR code for use to set up a new wire tunnel and user on the WireGuard app. For the simplest way to do this, you will need to download the WireGuard app and scan the QR code that the Pi has generated. We then need to set up a local 2net account to use with our Pi. After we set up the local 2net account, we can now go back to our Pi command terminal. On the local 2net website, we find how to install the Linux version of ARM. We should also make sure that this file being installed is being installed on the 32-bit library. To connect our Pi to the local 2net, we are asked to enter the authentication token, which is found on the local 2net dashboard. If the connection to the local 2net and the Pi was successful, the connection status will state connected in the command terminal. The next step is to create the UDP tunnel. When creating the UDP tunnel, the VPN on my phone presented problems. I was not able to connect the first couple of times to the Pi as I tried to. I looked at my settings and thought that something was wrong for the settings of the client. This was not the problem as I changed it and the handshake could not be completed. I took to Google to figure out what I had done wrong. With enough searching, I found a form stating that you need to change the endpoint in that WireGuard app. I then changed the endpoint in the WireGuard app to us2.local2net.com 46263, which fixed my problem. The UDP tunnel can be set up for 127.0.0.1 port 51820 while being sure to use a US server. Once we created a tunnel, we need to start it. Using the hostname and the port output by local 2net, we type in us2.local2net.4623. This is followed by us changing the endpoint field for your VPN client on the phone we have connected to match this. Using the command Pi VPN-C, we can see the virtual IP address as well as the remote IP address once WireGuard is up and running. I knew that the VPN was connected to my phone after I saw the notification pop up on the screen. I am happy that this project demonstrated a fantastic way to see how DNS servers work and how they can be used on a small scale and large scale for schools and businesses. I'd like to be able to learn more about this in future classes that I take. I think most importantly, the takeaway from troubleshooting is that the internet is a great source. There are loads of people who have some similar problems that can offer some useful advice. Finally, I noticed that even though there are tutorials for these projects, they don't work some of the time, and we need to figure out stuff on our own.